Hello! In this tutorial I'm going to show you how you can make a Souls-like elevator for use in your games. This is the type of elevator that has a pressure plate that you push down on, and then the elevator starts moving either down or up, and it usually has only two locations. So let's begin by creating a new blueprint class of type actor. Call this bp_elevator base. And open this up. Now in the viewport we are going to add a static mesh. I can just add a cube like this. And then let's make this numlock was off. 0.2, and then let's make it I don't know, 4 by 4 meters, something like this. Attaching to this we will I'm going to duplicate the cube and call this pressure plate, and I'll call the first cube the platform, like so. Attach the pressure plate to the platform, and let's move you up a bit. And scale you down to 0.4. So this pressure plate is now 1 meter. And this may be a tad small. I'm going to turn off the snapping. And add it at a height of 60, and let's make this just 1. Let's try a height of 90. There we go. That's a pretty big pressure plate, but it'll do for now, I think. Oh wait, let me just... Alright. Then attaching to the pressure plate, we will add box collision. So this collision box it'll have just a box shape. Now I'm going to make this slightly smaller than the actual plate, which means it's going to activate only when the character is fully on the pressure plate instead of just a small amount. So let's go with this, and I am going to set hidden in game to false so that we can actually see it, and set the line thickness to 1 just to see it a little better. Let's see, what else do we need? Oh, I can just attach this box to the platform instead of the pressure plate, sorry. Then we need 2 billboard components. I call this billboard top and billboard bottom. We're not going to move these yet, but these will be used to see the locations of the top and bottom parts of where the elevator is going to move. So let me find this and spawn it, see how this looks. It's obviously not going to do anything just yet, but this looks just fine. Yeah, let's go with this. So, in the event graph, I'm going to get rid of all this, and I'm going to click on the box and scroll down here to the event dispatcher for begin overlap. Put this here. And then we are going to check if the other actor is not equal to self, so that we make sure we do not overlap ourselves, which could happen if we're moving the pressure plate down and it moves like this and into or outside of the box. That means it could just have overlapped with this component, which is a part of itself, which means we need to check if it isn't itself. Otherwise we'll run code on overlapping with the pressure plate. I'm also going to add a variable, call it moving, and it needs to not, oh, I need a not boolean, here we are. So it needs to not be moving. Let me get an and, combine these, and then drag out and press B to create a branch. So what happens is we overlap the component, which means we are going to push the pressure plate down and begin movement. But before we can do that, we need to make sure we are not currently moving and we are not overlapping with ourselves, which is the pressure plate or any other component of the elevator. Once that's true, I'm going to create a new custom event and call this pressure plate down, like this. And then from here we call pressure plate down. So all these conditions are met. We are going to push the pressure plate down, and we are going to use move component 2. This node is what we'll be using for most of the elevator logic, because we are also moving the entire elevator to the billboard top and billboard bottom components, which means we can use the relative location of these to the rest of the elevator to move it where it needs to go. We're using this instead of timelines because I have found timelines to be rather inconsistent with this. They tend to change depending on your frame rate, because timelines tend to use a similar technique to event tick, which means it depends on your frame rate, which means with higher or lower frame rates you could end up in different locations. Another thing I've noticed with timelines is that they tend to mess up when you change time dilation. So if you have a gameplay feature where you can slow down or speed up time, that tends to mess with elevators using timeline components, as well as the fact that you can't change the speed on a timeline component, meaning you would have to use weird multipliers, which just leads to more complications and stuff. So we are using the move component 2 instead. So which component are we moving? We are moving the pressure plate. Where are we moving it? We are moving it to, let's create a new variable and say pressure plate pressed of type vector, and duplicate this to a pressure plate normal, also a vector, and let's see, pressure plate pressed should be, let's try 60. So I'm just editing the z value here, which is this z. So if I move this to, okay, so it was at 60, now it's at 10. 10 seems like it's a good amount for it to be pressed. So here we say 10, and the normal will be 60 because that is what we already had. So when it goes down, it goes to the relative location of pressure plate pressed. Relative rotation is the same. However, if we are creating children, we may want to rotate. So I'm going to say get relative rotation and plug this into here. So basically it's going to set the rotation to whatever it already is, meaning this value is ignored, but at least it's not being set to 0. You could check these in and outs. I'm not going to, and over time I'm going to make 0.5, which means it's going to take 0.5 seconds for this to complete. Then I'm going to set, oh, I meant to set, so drag out and hold Alt to set, moving to true, because now we have pressed the pressure plate, which means we are moving, or at least about to move. So I've noticed playing those Souls games that there's always a slight delay between when the pressure plate is fully pressed and when the pressure plate actually starts, or when the movement of the elevator actually starts. So I'm going to drag out and press D for a delay. Let's make it half a second again. And then we are going to create custom event. Call this move elevator like this. And call this custom event here, move elevator. There we are. So then in the move elevator, we are going to move component 2 once again. The component to move is the platform. And the target relative location will be the relative location of either the billboard top or the billboard bottom. So we say get relative location, target select. Oops, need to move these. And let's create a new variable and call it is going down. Create this as a boolean and make it instance editable, and I'm also going to move it above here. So is moving down or is going down. If we are going down, then we need to go towards the bottom. If we are not going down, so going up, we are going to the billboard top. So we use this relative location as the location to go to. I am going to check the ease in and ease out for smoother elevator movement. I am going to do the same thing as what I did with the other one, so get relative rotation and add it here to set it what it was. And then for the time, we are going to do something special. We are going to we're going to duplicate this and also get the platform relative location, and then find the distance between these two. So this is going to get how far the elevator needs to travel to reach its destination. We are going to divide this by, and let's promote this to a variable and call it speed. Let's make sure it's instance editable, and also we are going to set a slider range. I looked it up and the average speed for an elevator is 1 to 7 meters per second. Now I'm going to only set the slider range, not the value range. In case you want one that goes super fast, you still could, but it will be a little bit clearer that 1 through 7 is a more common or average speed. And then here we can say units. And in the units, we have a lot of different things, including meters per second. So if I now compile and save this, and we look at this one, under the default category, we can see speed. It's not just a number, but it also tells me it's in meters per second. So then we are going to divide this by 100. Because otherwise this value will still be in the wrong kind of unit, so not meters, but so not in meters, but in hundreds of meters. And this is what we will use for the time that it would take to reach it. So that's the distance divided by the speed and also divided by 100. So once this has completed, we are going to set moving to false. And we are going to set is going down to whatever it is not. So this is basically going to invert the value. And then once this is done, we need to reset the elevator. So let's go and create a custom event. Call this attempt reset. I've noticed playing the Souls games that the elevator doesn't reset immediately when you get off the elevator or off the button, but rather it waits for a moment before resetting itself, so you don't accidentally press the pressure plate again when you didn't mean to. So we are going to call the attempt reset once the elevator is done doing its thing. So I'm going to check, don't need a delay, I need a retriggerable delay of 1 second. And I'm going to go and do a sphere trace for objects. So the start location will be the location of the pressure plate. So we get world location on this. And the end will be slightly higher, so we add half a meter to the Z, like so. The radius, I will go with something like 25 centimeters. And for object types, we are going to say make array. And the type will be of type pawn. Let's see, I'm going to draw the debug for a duration, and draw time will be 0.25. So then, we are drawing a trace to see if there is a pawn, which is usually going to be the player, still on top of the pressure plate. If so, we are going to say create a new variable and call this wait for end overlap, which basically means we need to wait until the player steps off the pressure plate. Then we are going to run a branch from this, and if it is true, we are going to repeat ourselves. So, is the player still on top of it? Yes, then check again if the player is still on top of it. If the player is no longer on top of it, then we're going to add another custom event and call this pressure plate up. Call pressure plate up from here, from the false, and let's call the pressure plate up, which will be the same as the other, so move component to, the component being the pressure plate, of course, and the target relative location of pressure plate normal, and we are going to get relative rotation and plug it into the rotation, like so. Oh, and in the time, let's make it half a second again. So we still have this wait for end overlap to do. So let's go to the box collision, scroll down to the event dispatchers for event overlap, end overlap, excuse me. I'm going to put this here, which is why I left the space, so we have two overlap thingies close together. I'm going to make a branch, the conditions being moving and wait for end overlap, so we need to not be moving, and we need to be waiting for the overlap event. If this is both true and we have ended the overlap, then attempt reset, and we need to set wait for end overlap to false, because we're no longer waiting for it, it has happened, so we're going to set it to false. In the construction script, we're going to add two new variables, call this location top and location bottom. Expose these so they're instance editable. Then we get location top and we say billboard top sets relative location to location top, and we do the same thing but with location bottom and billboard bottom, and then we are going to set the relative location of the platform to this little calculation, but instead of using this, we are going to use just select from is going down and get the location bottom and the location top. So one thing to note is that we do now have to set the location top and bottom values manually. But that's alright, we can just drag them. Oh, that's a bit high. Let's go 500, is that what I had? 600. Good enough. And now if I check is going down to false, which means it starts from the top and... oh, that's reversed. Whoops. I'll just add it not be. Like so. So now is going down is false, which means it's going from the bottom to the top. And is going down is true, which means it's going from the top to the bottom. So now if I start here at the top and I activate it, it's going to go down. And then I can press it again to go up. That's usually how elevators work. So another thing to note is that this is all using components. Now another way to do it would be with a skeletal mesh, which would be more consistent given the fact that some use an origin point that is in the middle, whereas others would use an origin point in the corner. So like right on the corner, and then that would mean that if you spawned it, it would look a little bit like this, because the corner is now the center of the, or is now the origin point, which means the origin point is at the proper location, but the actual pressure plate or the thing wouldn't be. So you would have to go and set that manually every time you make a child. So if you were to use a skeletal mesh, you would just have the skeletal mesh always have the same approximate origin point, which in this case would be the center, and then work from there. I will touch on how you can make that in Blender in the next video, but for now I hope this has been helpful. If it was, please let me know by leaving a like. If you have any questions, feel free to leave those in the comments. I will do my best to answer. And that'll be all from me then, and good luck.